Okay, so what we're going to do today is we're going to use these little models, these games, to kind of go through the basic paradigm, right? And the basic paradigm is DNA is replicated into DNA, right? And then it is transcribed into RNA, and then it is translated into protein. And you're going to eventually take a piece of DNA and make a protein which will only be 2 amino acids. So let's start off by deciding what our pieces are, right? So everybody go ahead, let's find out the 4 bases here on the DNA bases. So go ahead, take your pieces, right? And you should see that's a C, that's cytosine, right? And then what do we got here? That's an A, that's adenosine, right? And then we should have T, that's thymine. And we should also have, who did I leave out? G? Where's G? Find me a G. Okay, that's guanine. So those are the 4 pieces. You're going to have to get them out of your boards to start with. Now don't take out the uracils, right? We're not going to use the uracils yet. So get those 4 pieces out. You're also going to need the phosphates, right? So let's take a look at the phosphates. Who are the phosphates? Those are these yellow little guys here. Okay? So you need the phosphates. So we're going to have to get a pile of phosphates, get all your pieces there. And who are we missing? Who else is missing in the nucleotide? So we got the bases, the phosphates. Who else do we need? Now there's 2 sugars in here, right? They're both 5-carbon sugars. One is pink and one is red, right? Like this? Okay. One is deoxyribose and one is ribose, right? We want the deoxyribose. Who's the deoxyribose? Is it the red or the pink? Deoxyribose. Who's the... No, it's the red one, because the red one, look on the pink. See the oxygen here? So it's missing the oxygen. The red is missing the oxygen, so you want the red ones to start it with, okay? Now here's what I'd like you to do. I would like you to go ahead and make the double-stranded DNA. So you're going to have to put in all the bases, all the phosphates, and all the sugars, and you're going to go ahead and make this strand right here. I want you to make a double strand, so ACC-TGC, that'll be strand number 1, and then go ahead and put in the complementary strand number 2. So let's stop now. Okay, if we all did it right, it should look something like this. Now we're putting in the complementary double strand, right? Now they put in a sequence ACC-TGC. Let's make sure that they did it in the right polarity. It should go 5' to 3'. There are 5 carbons on the sugar. Here they are. 1, 2, 3, 4, and that one there is 5. So if this is 5, 1, 2, 3, that's 3 over there. 5 to 3 goes in this direction, ACC, and they did it right. And then they went ahead and made hydrogen bonds. See the hydrogen bonds there? They made hydrogen bonds and they hooked up the other bases and they put in the other strand there. Go ahead now and fill out the sheet for the first part there, and we can stop now. Okay, let's go. So now that you've gone and done replication, let's go to the next part of the basic paradigm. Let's transcribe into RNA. So we only need 1 sense strand of RNA to do it for. So here's what we're going to do. Remove strand number 2. So strand number 2 was this one here, right? So sorry about this. We're going to take this away. And what we're going to do is we're going to use strand number 1 as our template. That'll be the sense strand. And we're going to now not put in a DNA complementary, but let's go ahead and put in the RNA complementary over here, right? Now remember the difference. You have to use the ribose sugar instead of the deoxyribose. So we're going to use the pinkies, right? And every time you'd want to put in a T, we don't put in a T, what do we put in? So you put in the uracil. Go ahead and make the single-stranded RNA now. Okay, so if I could just see your sheet for a second here so I can follow along there. Great. Go ahead. Okay, now what I want you to do at this point is I want you to now remove the DNA strand. So we're going to take this strand away, guys. We're going to take that away. We're only going to be left with the RNA strand over here, right? And what you're going to do now is you're going to run it through the ribosome. So you're sitting right now in a big picture of a ribosome, right? And what you're going to do is you're going to add in the correct tRNAs, right? And they're going to be carrying the correct amino acids, right? Now you only have 2 different ones here. You have glycine and you have what, alanine? So those are the only 2 possible choices you can have. And you'll see that there's other pieces over here, right? And these guys are the amino acids and these guys are the Remember we drew this the other day, the tRNAs. So you want to go ahead and put these guys in there to see who the final enzyme is going to be. Okay, so now we have our final product here. We put our tRNAs in here, and we put in our amino acids with our activating enzymes. And we have two different amino acids, glycine and alanine. And the question we've been debating is which came first, the glycine and alanine, or was it alanine and glycine? Okay, let's look back here. Remember that our sequence was, it started as ACC. It started at ACC. ACC should have been made into RNA. It should have been made into UGG, and therefore UGG should code for the first amino acid, and UGG is this guy, so the first one should have been glycine, and the next one was alanine, and that is our 2 amino acid protein. Hey, you can go ahead and disassemble it and put it back there.